Did you read the news today? Scroll social media? Watch the YouTube video? Every day. We exchange a tremendous amount of data. They are processed in huge data centers with servers running non-stop. They need power supply and cooling, resulting in energy consumption and CO2 emissions comparable to aviation. We demand more, faster sharing, better quality. Can the technology keep up without increasing energy use? Maybe, with use of light. Well, not only the visible light. Light propagates as waves with a wide spectrum of frequencies. Light consists of photons, so a science of manipulating light is called photonics, analogically to electronics, which transmits signals with electrons. Electrons are heavy and slow compared to photons, which are massless and travel at the speed of light. With many distinct frequencies, photons can carry lots of data over long distances. They are easier to move and generate less heat, making optical communication more energy efficient. We already use fast internet with optical fibers to send data quickly, but when we want to do something with the data, we convert optical signals to electrical and do all the computations with use of electrons. Why? Our computers perform logical operations with use of silicon transistors, encoding signals as zeros and ones with low and high voltage. If we only could build optical transistors. Good news, they already exist. I have one here. It consists of two channel waveguides and a ring resonator. This transistor is a switch. When it is off, light in one waveguide does nothing. However, when tuned with laser, the ring resonates at the frequency of the input signal. The switch is on and sends the signal to the upper waveguide. These transistors can already build functional systems. So why do we still use electricity instead of lasers to power our laptops? Because modern silicon transistors are cheap, tiny, and stable. In contrast, optical transistors are bigger. Photonic systems are sensitive to manufacturing inaccuracies, causing transmission losses. This may change the output of the logic systems and lead to errors. And this is why we work on better understanding of light propagation in optical structures. We optimize their shapes and improve manufacturing methods to make our future light.